These field results from the company Earth in Trinidad demonstrate the clear advantages available from the use of our advanced electrocoagulation systems. As you can see, before the treatment, the raw slop oil had a mixture of 79% oil, 20% water, and 1% bottom sediment. After the treatment, we were left with 99.94% oil, 0.01% water, and just 0.05% bottom sediment. The second problem is a hidden Gulf danger of radioactive contamination. Reports are circulating that there have been high levels of radioactive substances in the crude oil and the produced water that was spilled into the Gulf region. Now, this is not surprising when you know that the EPA reports that the geologic formations that contain oil and gas deposits also contain naturally occurring radionucleotides, which are referred to as either NORM, naturally occurring radioactive materials, or TENORM, technologically enhanced naturally occurring radioactive materials. TENORM results from the extraction process concentrating the naturally occurring radionucleotides, thus increasing the risks of radioactive contamination. Gulf wells have higher radioactive concentrations. An estimated 30% of domestic oil and gas wells produce some TENORM. In surveys of production wells in 13 states, 90% of Mississippi wells reported high concentrations of radionucleotides, while only a few or none reported high concentrations in Colorado, South Dakota, and Wyoming. So where does this radioactivity come from? Well, much of the petroleum in the Earth's crust was created at the site of ancient seas by the decay of sea life. As a result, petroleum deposits often occur in aquifers containing brine or salt water. The radioactivity levels in produced waters, the water that comes up with the oil, are generally low, but the volumes are large. In older wells, up to 10 gallons of produced water are brought out of the ground for each barrel of oil, roughly 20%. In newer wells, the ratio is lower, but still significant. So, with about 250 million gallons of oil spilled, that means that millions of gallons of radioactively contaminated produced water have also spilled directly into the Gulf waters. It is these produced waters which contain the concentration of radioactive elements. This means that in addition to removing the oil, the produced water also needs to be treated effectively. This chart from the EPA illustrates the range of radioactivity to be found in wells. As stated earlier, the wells in Mississippi and the Gulf have the highest levels. Now, there don't seem to be any clear reports which indicate the exact levels of NORM and TENORM in the Gulf waters due to the spill, but since the radiation is still present in the produced waters, even if the oil is removed by the Costner centrifuges, the tainted water that will be discharged into the Gulf could result in a strong ongoing liability for everyone involved. The solution to radioactivity. Removing radioactive substances. Our electrocoagulation equipment effectively removes any radioactive substances that are present in the produced water. Even the sludge generated ends up in a more environmentally stable form, thus reducing disposal concerns. The electrocoagulation test results shown below are from the work performed under the auspices of the U.S. Department of Energy by the University of California Lawrence Livermore National Laboratory of Bill Daley, Jr. As you can see here, the contaminants including americium-241, plutonium-239, radium, and uranium all have a removal rate of over 99%. The radioactivity has been handled. Step 2. Eco-remediation. 2 solutions to fill an urgent need. Eco-remediation is based upon taking what's best and most effective in nature's toolbox, putting it all together intelligently, and using the combination to assist and accelerate the planet's natural healing process. Nature often has the best and least destructive solutions. The 2 primary tools we'll be using are enzymes and bacteria. The 5 problems we'll be looking at in this step are marshland delicacy, oil blooms, BTEX and the people getting sick from it, tar balls in asphalt, and devastated wildlife. First, let's look at the problems, and then the 2 solutions that handle them all. First, we'll look at the delicate marshlands. Marshlands are extremely delicate. Ordinarily, the marshlands are a rich source of natural bacteria, but once they've been invaded by a major man-made imbalance, they need special remediation. Machinery, and even human presence, such as walking through the marshlands, can do a great deal of damage to the delicate marshland ecology. But the oil still needs to be cleaned up, and it needs to be cleaned up quickly. Many of you may have heard of the oil blooms in the Gulf. Well, it has been reported by the University of Florida that transparent underwater oil blooms do in fact exist and are considered to be an environmental threat. A good way A good way to imagine oil blooms is picturing them as very light, wispy, and almost transparent underwater clouds. These blooms are presumed to be caused by microscopic globules of oil, which are created by the controversial chemical dispersants being used, around which small bubbles form. The globules and bubbles are so small that they're very hard to see. The bubbles keep the oil from sinking to the bottom. These microscopic globules of oil are ingested and absorbed by tiny marine life at the bottom of the food chain, which are then consumed by larger and larger fish, including fish and other sea life consumed by humans. People getting sick from the spill. There are people getting sick around the Gulf oil spill, and the culprit seems to be a chemical compound called BTEX. BTEX is an acronym that stands for benzene, toluene, ethylbenzene, and xylene. This compound is categorized as a volatile organic compound, or one of the VOCs. They are recognized by the EPA as having harmful effects on the central nervous system of humans and animals, aquatic and terrestrial. There are many ailments that have been linked to BTEX. BTEX components have been associated with skin and sensory irritation, central nervous system damage, depression, headaches, and effects on the respiratory system. Prolonged exposure to these components has similar effects as well on the kidney, liver, and blood systems. According to the EPA, there is sufficient evidence from both human and animal studies to substantiate that benzene is a human carcinogen. Workers exposed to high levels of benzene in occupational settings were found to have an increase in incidence of leukemia. Exposure to BTEX can occur in several different ways. First, by ingestion, consuming water contaminated with BTEX. Also by inhalation, exposure to BTEX present in the air around the Gulf, because VOCs evaporate easily from waters at normal temperatures. Also through absorption, right through the skin. Final way is by consumption, exposure from the consumption of foods, plants, animals, fish, contaminated by BTEX themselves. I don't think we need to stress how critical and urgent it is to handle this BTEX so that the people of the Gulf and the workers in the Gulf are safe. Another one of the side effects of the oil spill is the creation of tar balls and asphalt, which takes hundreds of years to degrade. Now we'll take a look at the wildlife devastation. A great deal of damage has already been done to the delicate ecosystems along the Gulf Coast that could have a negative impact for many years to come due to the destruction of the wildlife incubator where much of the vital life of the region is bred. Additionally, as mentioned previously, the contamination of the ecosystem can make people sick, and it's not just limited to the Gulf. The wildlife must be attended to, and it must be done immediately. Now, first things first. There is a misconception that we must be aware of, which is that helping the fish and wildlife is simply altruistic or green. The fact is that by air or by sea, these animals migrate, and they are all part of a complex food chain which humans may end up consuming no matter how far they are from the disaster. If we don't handle their habitat, and quickly, the animals that do survive the disaster may be too toxic for consumption. It's also worth noting that this toxicity could infect the animal's genetic makeup and be passed on to future generations. In this way, areas which seem to be detached from the disaster may well end up being poisoned by its effects. What we should get from this is that the disaster is not merely about the environment and that it is not isolated to where we can see the oil flowing. We are all in this together, and the cleanup must be done immediately. This brings us to our two powerful natural solutions. The first is Ecoenzyme 100, and the second is our oil-eating bacteria army. Oil-eating bacteria. Can they be a solution? Oil-eating bacteria are nature's way of biodegrading oil. They are a completely green solution. They consume the oil and produce a nutritious fertilizer when they're through. So why aren't they handling the crisis? These bacteria actually have been used effectively in handling previous oil spills, like in the Exxon Valdez remediation, for example, not to mention the 23 tons of these bacteria which are currently being dispersed by the Chinese government to help deal with their oil spill. However, in order to effectively handle such a large concentration in the shortest time possible, the bacteria need some assistance. Can you speed up the natural process? Yes, it can be done. In order to speed up the process so that further damage to the ecology can be avoided, these bacteria need enzyme reinforcements. Ordinarily, the marshlands are a rich source of natural bacteria, but once they've been invaded by a man-made imbalance, they can be overwhelmed and need some heavy artillery support.